right. Good evening, grade 11s. I hope you're well. I think first, trust. All right, so we are going to be looking at grade 11 maths revision. Okay, and why are we doing grade 11? It's because grade 11s are writing on Friday. Some of them. I only know grade 11 maths students that are writing on Friday. So that being the case, I think it's high time we did a revision session for the grade 11 so that at least we can have them covered, you see. Let me just... Yeah. So for the purpose and the intent of this live, let me just for a moment all right, I'm sorry about that. I just needed to maneuver some stuff. So for the purpose of this live, guys, I just want to, before we jump into what we have prepared, it's very good to be sobered up about what we are getting ourselves into as grade 11 learners. These guys are making so much noise. Yo, too much noise. Okay, guys, let's be very much aware of the following here. Okay, so I'm just showing you grade 11 learners what is the makeup of the paper that you guys will be writing, because the mark allocation will give you an idea as to the time distribution and the time allocation that you need to have in preparation for the exam. So there, if you look at the middle column, okay, Mr. Mac loves paper one so much, you're funny. We'll definitely do paper 2 when the time comes for paper 2, so chill, guys, right? But I get you. So there we have functions, which is like 45 plus minus 3 marks. If you look at functions and general algebra, okay, we have literally a range of between 90 marks, or maybe even at best you have 96 marks at best together if you have maximum marks for both, right? 96 marks. Now out of 150, guys, 96 marks is already quite a big chunk of marks. So that means your functions, guys, that's where the marks are lying, and your algebra, equations, inequalities, nature of roots, exponents, your sets, your equations, the works, those are where your marks are. So we need to make sure that those marks do not go to waste. We can't have those marks going to waste. And the functions as well, guys, those need to be sorted out. And then if you look at the last 3 topics, patterns, which are number patterns, linear and quadratic, financial maths and probability, between them you have the 60 marks, right? You have sort of like, I guess you could say, a range of maybe 55 to like 70 marks at best that you can actually get from those questions. So your bulk of marks are lying with functions and algebra, and then your patterns, financial maths, and probability. Obviously, I'm not saying we need not take care of them, but we need to. But most importantly, we need to make sure that our functions in the algebra is really, really good. Okay, because your algebra is going to affect your number patterns, your algebra is definitely going to affect your probability, and your algebra is going to affect your financial maths. So that is why your algebra is going to affect your functions as well. Okay, yeah. So let's please ensure that at best our preparation is top notch, so that we don't find ourselves crying, okay, weeping and wailing, gnashing our teeth. Okay, now I don't know if anybody has any questions before I jump in, and we can look at, I guess you could say, I am going to be looking at various different types of questions, and here before us we're going to start at the most basic and just move with the questions. So these are the questions we'll be looking at to start off with. Okay, so the very first question I think is a very straightforward question, 3 marks. That is just a nice giveaway. All right, and I think people obviously will know what they need to do here if they're going to solve for x. Here's another nice giveaway. Hopefully this is also a nice, beautiful giveaway, and we are aware of what we need to do here. This is a nice fraction equation. Hopefully it's a nice giveaway again. Another one, and then another one. And then most importantly, being able to get into the interpretation of this so that we know what ought to be done. So let's start there at the top. 9x squared minus 81 is equal to 0. We need to solve for x. So for the benefit of those that maybe feel like, yo, it's been a long time since I've done algebra, I am going to do this step by step, and I'm going to say, we know, guys, that there is a procedure that we follow when we are doing equations, and that procedure we need to consistently follow through with it in the way that we know it ought to be followed. So these questions here, 1, 2, 3, 4, 5, 6, 7, are all about following procedure. They're all about following what? Procedure. Okay. Yeah, grade 11, guys, grade 11. We are here. Right, we are starting with algebra. And what did we say? General algebra. How many marks did we say this section has? It's plus minus 45 marks of the entire paper. A big chunk of marks that we definitely need to make sure that we get, no doubt. So let's look at the first question. Solve for x. And yes, I think Livia is right. Mr. Mac does love paper 1. He's obsessed with paper 1. Addicted to paper 1. So 9x squared minus 81 is equal to 0. Let's move. We're going to move with each question, and you guys can help me out in the comment section. Yeah, you can help me out a lot. So what do we know when we are doing or solving these questions? Step number 1, we need to make sure that the equation is in SF, which means the equation must be in what? Standard form. What is standard form? This is when we have the equation in the form of ax squared plus bx plus c is equal to 0. So currently, our equation here is definitely in what? In beautiful standard form. All right? That's where the equation currently is. It is in standard form. Then 2, we need to do what? We need to f. Okay, please guys, this is not a swear word. We need to factorize. Okay? Now, if we look at this question, this equation, this expression on the left-hand side, it's an equation when it has an equal sign with a right-hand side, but 9x squared minus 81 is an expression. Okay, we can do what with it if we are going to factor? We can take out a highest common factor, which is what in this case? Remember, when we take out a highest common factor, we take it out according to the sign, the number, and the letter. So if we look at the sign, the first term is positive. The highest common factor number that we can see between 9 and 81 is what, guys? It is 9. All right? It is 9. So that highest common factor for an equation, what do we do with it? We don't take it out if it's a number. If it's a number, we take the highest common factor, we divide by it. We divide by a number, highest common factor. We would take it out and keep it out and not divide by it if the highest common factor was a what? Was a number with a variable. But if it is a number, guys, we just simply divide by that highest common factor. So if it's a highest common factor, that highest common factor is a number, we divide by the number highest common factor. But if it's a highest common factor and it's a number with a variable, then we would take out the highest common factor with its variable. Okay, so those are two important things that we need to note. If it's a highest common factor with a number, we simply divide all the terms in the equation by that highest common factor number. But if it's a highest common factor number with a variable, then we must take out the highest common factor with the variable and not divide by it. Very, very important what I'm saying here. So we have 9x squared minus 81 is equal to 0. The highest common factor is a number. So what do we do with it? We divide all the terms by that highest common factor because it's a number. Then what do we get? X squared. What's 81 divided by 9? It is minus 9, which is equal to 0. Now, after dividing by that highest common factor number, what do we get? X squared minus 9. What can we do further as far as factorize x squared minus 9? The expression on the left is what we call a difference of two perfect squares. A difference of two perfect squares. So we'd simply open two brackets. Okay. One of the brackets will be positive and the other one will be negative. Then the square root of x squared. What is it? It is x and x. The square root of 9 is 3 and 3. So this is x squared minus 9 factorized using what we call a difference of what? Of two perfect squares. Okay. So then after factorizing, step number 3, when we have factorized fully, all right, where we have gotten to a point where we have our product of factors, then we will apply something called the what? The zero factor law. The what? The zero factor law. Sometimes they call it the zero product rule. So in other words, if there's a 0 on the right hand side and you have a product of factors, what we can say is that x plus 3 is equal to 0 or x minus 3 is equal to 0. This only applies if there's a 0 and a product of factors. Then ultimately we can say x is equal to negative 3. We take the 3, we transpose it to the right, it becomes negative 3. And then we say x is equal to positive 3. And that's simply the two answers that we get for 9x squared minus 81. Of course, we are expecting to have two answers. Why? Because this is a quadratic. X squared means this is a quadratic equation. And as it is quadratic, what are we expecting at the end? We are expecting or anticipating to have at least two answers. All right. So that's why there you can see that we have x is equal to negative 3 or x is equal to 3. We call these things the roots of the equation. What do we call them? The roots of the equation. The roots of the equation are simply the solutions for the equation 9x squared minus 81 is equal to 0. Okay, I hope that makes sense. Number 2, question number 2 in our paper is 3 into x squared minus 5 is equal to x. If you're saying, or critical values, definitely. Or we can call them critical values, or one other thing. In functions, what do we call them, Ify? I love what you are saying. So these values of x, we call them roots as solutions of an algebraic equation. In inequalities, we refer to roots as what? as critical values. In functions, we refer to the roots as what? As x-intercepts. Okay, I love that you can still remember that, Evile, right? We call them roots in algebraic equations. We call them critical values under the topic of inequalities, and we call them x-intercepts under the topic of functions. Why do we call them x-intercepts under the topic of functions? Because whenever you let y be 0 and you solve for x, you get what we call your x-intercepts, which in inequalities we refer to them as critical values, and in equations we refer to them as the roots of the equation. So thank you so much for that comment, Ivile. You are heard. You are truly heard. 3 into the next question. X squared minus 5 is equal to x, right? Is equal to x. Okay, so here we have a number that is multiplied into x squared minus 5, which is equal to what? To x. So what we first do then is we're going to distribute this 3. Why? Because remember, our equation has to be first written in what? In standard form. What is standard form? Ax squared plus bx plus c is equal to 0. Is it currently in standard form? No. So that is why I am taking this 3 and I'm distributing it into the bracket. There's 1, 2 terms inside the bracket. So when I distribute the 3 inside, no, I haven't. I'm still starting. This is just the beginning. 3x squared minus 15 is what we get on the left hand side. This equal to x is on the right. So then after that, we are going to transpose the xy because we want to get the equation in standard form. So we're going to get 3x squared minus x minus 15. How did you get minus x? Remember, the x is on the right hand side. So when we transpose the x to the left, the x term becomes negative. It was positive on the right, but when it transposed to the left hand side, the x term becomes negative. Hopefully that's very clear for all of us. Then when we are at this stage, does zero product law only apply for 2 or more brackets and not on the situation? Yes, very true. So zero factor law applies when there's a 0 on the right hand side. So for instance, we would never say with this 3 is equal to x or x squared minus 5 is equal to x. We would never do that. Why? Because on the right hand side there is no 0. Are you with me? So since there's no 0 on the right, that means to you, get your equation into standard form. Here we already had standard form. So we went on to the next step. We factorized. That's the procedure. Then we went on to the next step. We got our factors, the product of factors. There is a 0 on the side. So that means we can now move on to the next step, which is apply the zero factor law. So then we have our independent factors, x plus 3 and x minus 3 equated to 0 because we have the 0 on the right. And then we can get our roots, solutions, critical values, or x-intercepts as we call it in functions. So in this situation, we have a 3, we have x squared minus 5, we have x. We can't apply the zero factor law. So what does that mean? We must first get the equation in what? In standard form. So this is our machine as we take the 3 distributed to the x squared, take the 3 distributed to the minus 5 using multiplication because brackets mean multiplication. So 3 times x squared is 3x squared, 3 times minus 5 is negative 15 equal to x. Then after that we transpose the x to the left. Why are we transposing the x to the left? It's because, guys, we want to get the equation in what? In standard form. So if we take the x over, it becomes negative x minus 15 is equal to 0. Now when we are at this stage, right, many kids look at this and they're like, ish, factorizing this is going to be a pain. So after getting the equation in standard form, you can either do one of 2 things. If you can factorize, go ahead and factorize. But if you feel that factorization for you is a bit of a pain, then you can use this guy. Something beautiful, a formula that should be provided in your exams in the formula sheet that we call the quadratic formula. This quadratic formula simply goes like this. And if ever you feel like the factorization, I'll see you second half, then you can use the quadratic formula. It is a-okay to use the quadratic formula when you are at the standard form stage and you feel like factorizing is just not flying so well. So in the place of b, guys, all right, and in the place of a and c, what do we take? Remember, in standard form we have a, which is the coefficient of x squared, b, which is the coefficient of x, and then c, which is the constant term. So in our standard form here, what is b? What is the value of b? Let's see if guys really get what the value of b is here. What is the value of b? Thank you so much. It's -1. So in the formula, guys, please take note, there's already a negative sign in the formula, okay? So if there is a negative sign already, write the negative sign and then do your substitution of b. b is -1. Please, guys, I beg you, I beg you, I beg you. There's already a negative sign in the formula. When you substitute b, you know it's -1, so you substitute -1. And yes, Primrose, it will be positive when we simplify it. Okay, so for now, I'm just doing the substitution. In the place of b, I'm going to once again, in brackets, write -1 in brackets and put the square outside. Okay, it's different, guys, if you just write -1 and there's no brackets. You must write -1 and inside write -1 and the brackets on the outside. Okay, minus 4. In the place of a, we substitute what? What is the value of a? Yes, it is 3. Thank you, Primrose. And then c, the value of c in our equation that is in standard form. Thank you, guys. Thank you, Ivile. Thank you, Taurus. Thank you, Lady P. Amchelang, Primrose, OT, Ivile. Yes, it's a -15. Then we divide all of that 2 times the a value there. Our a value, guys, our a value is obviously going to be that 3. Then we can take our beautiful calculator, guys, right? So negative times the negative first is +1. Let's at least first write this in the third form. -1 squared minus 4 times 3 times 15. Sorry, let's just close the bracket there. Okay. Okay, so we have 180 here, and then this is positive 180. We add 1, so this is 181 in this bracket, in the square root there, over 6. Okay, right. Now, after doing that, I'm expecting you guys to help me out. Take your calculator, okay, punch all of this in. Okay, firstly, you are going to punch it in with just the positive sign alone. So omit the negative sign and punch in with your positive sign first. 1 plus the square root of 181 over 6 with a positive sign, and then tell me what's the answer that you get in the comment section. Then you are going to clear that positive sign and then do it with the negative sign and check what answer you get so that we can have both solutions. Amchelang, thank you so much. Amchelang says the answer is 2,41. Very good, Amchelang. Now, especially if the question is telling us from the instruction in the front. Whenever we jump into the question paper, the instruction in the front says, if necessary, round off answers to what? To 2 decimal places unless stated otherwise. And let me reassure you guys that in this particular question, all right, there was no indication of we must round off anything So there's nothing actually stated there. So therefore it means that our answer must actually be accounted as such. Okay, -2. This answer here, the second one, seems like we are in agreement with 2,41 grade 11s. What about this one? If we now omit the positive sign and we write the negative sign, okay, then what is the answer there, grade 9s? Grade 11s. Okay, what is the answer if we don't put the negative sign? We write 1 minus the square root of 181 over 6. I see Amkhelang says -2,08. Are we in agreement? Is that the answer, the second answer? 1 minus the square root of 181 over 6. Do we get -2,08? Seems like Taurus is saying yes. Ndwane Kia is saying she is correct. So it's -2,08. Yes, because if we have 2, please guys, the rounding off must be done properly. If it's round off to 2 decimal places, make sure we round off correctly. At this stage, you guys should all be pros at rounding off correctly. Mabel Simeons, can I just suggest to you, guys, do not ever, and you don't have to, solve for x using by completing the square method. You use that method if they specify in the question to use that method. May I suggest that you use that method only when it has been specifically stipulated that solve for x by completing the square. Then by all means, go ahead and do that. If it has not been stated as such, you are free to write your equation in standard form, factorize if it is possible, and in the event that you feel like it is not possible, you are free to use the what? The quadratic formula, okay? You are free to use the quadratic formula, okay? Yeah. And according to the examination guideline, guys, the solving for x by completing the square method is not really examined, it's not really examined, the solving for x by completing the square method, right? So we rarely ever utilize that method unless an examiner decides that he's just going to put it in there, all right? So yeah, that is just something to note. So that's if they stipulate in the question, okay? In case they say we do it, in case an examiner these days. Oh, that is funny. Say you did not include 2 in the equation. Okay, now you need to, what 2 are you talking about? Catherine, 19857, what 2 are you talking about? Catherine, 19857, which question are you talking about? And which 2 are you? Oh, the 2 there in the, oh, Catherine. Catherine is saying to me, Catherine, you've got a, what do we call it? You've got a sharp eye. You've got a super sharp eye. Sure. W is for Catherine. Yo, I'm telling you. And yes, you know what? I love the fact that I was the one that made this mistake. So you guys can actually now do a party and you can celebrate. The host did a crazy mistake, but you know what? I'm gonna get away with it. I'm going to get away with it. But unfortunately, if you do this, what I did in the exam, you are going to get penalized for that error. All right, you might get penalized just 1 mark because now you have changed the original question, just like I have done. Okay, you have changed the question. You have introduced your own question. So guys, don't be like me in this specific situation. Be like Catherine. Have a very sharp eye and see what needs to be seen. So Catherine, thank you so much. Okay, how careless of me. Okay, hopefully you will not be as careless as I am. Guys, I'm really sorry for the noise, but I can't really control that noise that's happening, that you hear in the background. So 3 into 2x squared. 3 into negative 5. So Catherine, thank you. You have saved us. So we have 6x squared minus 15 minus x is equal to 0. Written in standard form, we would have 6x squared minus x minus 15 is equal to 0. Okay, I am glad when lessons are learned like this. You can learn from my big mistake, and then you make sure that in the test, you make sure after writing a question, after writing your question, make sure, just double check again. Did I write everything? You see, me, I didn't double check. I just wrote. Okay, I just wrote, which is dangerous. Okay, so with this particular question, the question would be, is factorization, is it possible? That is the $1 million question. Is factorization possible? Can we factorize this? All right, and like I said, guys, if you feel you cannot, and let's say factorization is possible but you feel you cannot, please don't hesitate to do this. Don't hesitate. Yes, you can. Do not hesitate to use the quadratic formula. Don't hesitate. Don't try and think about it too much, because the more you sit here and think about it, the more you're going to waste time. Don't hesitate to use the quadratic formula and be a pro. So obviously we know that's negative 1. B squared minus 4ac, that is negative 1 squared, minus the 4a, the c, over 2 times the a, which is 6. Now I'm waiting for you guys to gloriously lead me into victory this time round. Okay, unlike the other time. Okay, unlike the other time. So underneath that square root, what is my answer? I just want to write the number underneath the square root. Yeah, so that was definitely factorizable. Underneath the square root, just guys, I want to write the number first underneath the square root. So I need 1 plus this 4 times 6 times 15. What do I get? The number underneath the square root. I want to at least write this insert form. All right, with this resolved, that resolved, and then of course the 2 times 6 resolved. I just want to get what is the number underneath the square root. So if you guys would be so kind, I see you guys writing the answer, and I really appreciate that. Thank you, Lady P. Lady P, you are a lady, that's for sure. Thank you. So, Lady P, you are a lady. Amkhalang is saying 19. Is it 19 that's underneath the square root? Guys, now I'm being, now you guys are making me scared. What's happening here? So underneath the square root, it's 19, not 361. Must I grab my own calculator? I need more witnesses. I need more people to witness that it is. Dino was saying 361. 361 over 12. Under the square root, is it 361 or is it? It's 361. She must not include the square root. It's 361. She must not include the square root. Oh, okay. So the answer with the square root after the fact, it's 19. Oh, I see what you guys are saying. I wanted the number underneath the square root. Oh, I get you guys. Okay, thank you so much. Over 12. The root of it is 19. Thank you so much. I really appreciate it. Yes. But then, of course, that will be 19. I see. 19 over 12. Sorry, my bad. Okay. Yeah. then the two answers that you get, guys, should be fractions, which means this thing, you were able to factorize this thing. It's factorizable. The answers that you get shouldn't be decimal numbers, but they should be fractions. So the minute you actually punch this in, and the first time you get a fraction, you write down that fraction. You don't write down the what? The decimal. Please, guys, if it is a fraction that you get as your answer, you write down the fraction, not the decimal. Okay, so we get 5/3. That's one of the answers. Or x is equal to what? Thank you. So that's when you put the positive. You get 20/12, which is 5/3. I see. Then the other one, 1 minus, yes, -3/2. So you can see that this was definitely what? It was factorizable. We could factorize. Yeah, well, it was possible to factorize this thing. That's for sure. Okay. Yeah. It was definitely factorizable. It would have been 3x minus 5 is equal 3x minus 5 into 2x plus 3. 3x minus 5 into 2x plus 3. That would have been the factors of your brackets had you factorized. Okay, some people do this. They use this method and they use the quadratic formula, but they do it all in the calculator. Then they get these answers, and then what they do is they work in reverse. Okay, if you get a fraction, it means we can work in reverse. You cross multiply the x, you get 3x is equal to 5. Then you take the 5 over, you get 3x minus 5. That means that would have been your first bracket. You take the 2, you cross multiply, you get 2x is equal to -3. You cross multiply, you transpose the 2x minus 3, you get 2x plus 3. So imagine if you were factorizing this, you would get 3x minus 5 into 2x plus 3 is equal to 0. Then you would actually solve and get the solutions. So some people do that, all right? I've seen people that do that, where they can see that, hey, it is factorizable, but just it's going to waste my time to try and find the factors. So they will take their calculators, punch all of this in, get their answers as fractions, maybe write that on the side, and then they get these answers. And then all they do, guys, is simply, make sense? And then they get the factors. Okay, if you cross multiply, you transpose, you get 3x minus 5 for your first bracket, 2x plus 3 for your second bracket. And then this means that would be your factorization underneath all of this, and then you would solve using your zero factor law and get your answers, which would be 5/3 and -3/2. That's just something to note. Like I said, you don't have to do all of that. You can just use the quadratic formula and get to the answer. It's a great method too. Well, I'm glad you think so. Chauke. Okay, let's go and now proceed with the next question. Hey, my friends, look at this question. Look at the marks. Look at this question. What comes to mind, my beautiful, amazing maths gamers? X squared plus x squared plus 4 into x squared plus x minus 12 is equal to 0. It's good when we know what we see. When we know what we see, then we know what we see and we can do it. Zugwang Kido is saying, aye, that's easy. Very good. I'm glad that you see that it's easy. Okay. Does everybody see that it's easy? Does everybody see that it's easy? Then common denominator. Catherine says, yep, this is for grade 9 or 10. No, it's not for grade 9 or 10. This is for grade 11. What are you talking about? Okay, this is for grade 11 and even grade 12, obviously. Not even grade 10 is at this stage. Okay, right. So I hope we can see that, there is a what here. If we were to expand this, we will get an x to the power 4 in our equation with a constant term. That is dangerous. The minute we get x to the power 4, because we've opened two brackets and we FOIL, that means we are going to get an equation that it's going to be very difficult for us to actually solve. So what do we see rather? Okay, this is x squared plus x. This is an expression, x squared plus x, and it's repeated here, this expression here in the place of here. So this x squared plus x is a repeated expression for two terms that are separate. Very good, Kwazingubani. So we use what? Very good, Kwazingubani and JD. We use the K method. Grade 11s, please be aware of all the questions in question 1 that require K method. Once you are a person who is aware of the questions that require the K method procedure, you are one better than most grade 11 students that will be writing their paper 1 exam. Be aware of all K method procedure questions. This is one of them. When we have a repetition of an expression for different terms, which we can see one of these could obviously, if expanded, lead to an x to the power 4 term. We don't know how to solve x to the power 4 equations. So when we see that there's a potential of an x to the power 4 being unleashed in an equation, we must check, okay, is there a repetition of an expression? So that in that repetition of an expression, we can then use the K method to help solve the equation. So I'm sure people are busy and they are solving this equation. And very soon, I'll be getting answers in the comment section. So this use of the K method, K, you must remember, is the way to x. What did I say? K is the way to x. K will not be the final answer. We use K as a means to get to our value of x, our roots of the equation. Okay, Ntwaneki, I see you there. K squared plus 4k minus 12. Do you see that? The standard form of the K equation, so that we can get our K values. Definitely very good. I love this. So for x squared plus x, as Ndwana has said, you see now when I'm writing, I am so aware, am I writing everything correctly? I can't afford to have a situation where I do not write. I do not want that dear lady who called me out to ever call me out again. That was the first and the last time. So we let k be equal to what, guys? To x squared plus x. That's what we let k be. We let k be equal to x squared plus x. Then in the place of x squared plus x, we substitute who? K. What is outside this expression? When we substitute with k here, there's a squared. Plus 4. In the place of x squared plus x, we substitute k minus 12 is equal to 0. When we look at this, we're like, we are back in grade 9, solving an equation that is quadratic, where the coefficient of the k squared term is 1. So that means we are going to open 2 brackets. Okay, put our k's there, find the factors of negative 12, okay, which when we factorize, when we multiply, they must give us negative 12. When we add, we must get positive 4. When we multiply these factors of negative 12, we must get negative 12. But then when we add, we must get who? Positive 4. Catherine is like so aware. The factors Catherine is saying is positive 6 and negative 2. Then what do we do? We use the zero factor law, all right, and get the values of k. So obviously k plus 6 is equal to 0, k minus 2 is equal to 0. So k is equal to negative 6, or k is equal to positive 2. Now most kids then get here and they think, Geronimo, I've got to the answer. Woo-hoo. And then they celebrate because they think they are done and they move on to the next question. But what have they forgotten to do? It's like they are leaving their friend high and dry. Okay? Very high and dry. This that you set up here was supposed to be set up so that it waits for k to be attained. Once k is attained, we are supposed to substitute back these k values and get the values of x. All right? Yes, Ndwana Kia, we have to prove. Very much so. So what do? We say x squared plus x is equal to negative 6, or x squared plus x is equal to 2. And then from there, Aye. Tina we solve it. Tina we solve it. Tina we solve. Now, scary this one. This one? The factors of 6. If we multiply, we get 6. If we add, we get 1. Fishy, 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 fishy. So even if we put this in the quadratic formula, what happens is we get maths error, which means here there is no ndoni, there are no solutions. I mean, I can't even think practically of two numbers that I would multiply together and they give me 6, and they add them and they give me 1. Okay, so this here, all right, even if you put it in the quadratic formula, you're going to soon find that underneath your square root. And I think let's just see this practically, because it's very important sometimes to see these things, right? We can obviously see there's no factors. So let's just see when we substitute in the quadratic formula. B is obviously 1, right? So, but negative 1 times 1 will be negative 1. B squared will be 1 squared. For A will be 1, and the C will be 6. Over what? Over 2 times 1. So we have negative 1 plus, and please let's note, 1 minus 24 gives me negative 23 over 2. Guys, when there's a negative number under the square root, what do we usually say about those particular roots? When there's a square root under a root, we say that the roots are what? We say that the roots are non-real. Okay, the roots are non-real. So here, x squared plus x plus 6 is equal to 0 leads to what we call as no solution. But we take the second equation, x squared plus x minus 2 is equal to 0. It is already in standard form. So then we move on to factor stage. We find the factors. X squared is formed by x and x. Then obviously when the factors, the last term is negative, it means that negative 2 means what, guys? That means we're going to have different signs in our bracket, in our two brackets. But then because of this middle term, the highest factor is going to be positive. So that means we are going to have plus 2 minus 1. Be very careful, plus 2 minus 1. When we multiply these numbers, we must get negative 2. When we add these numbers, we must get positive 1. So then x is equal to negative 2, or x is equal to positive 1. This is our solutions. So back to the beginning. When we use the k method, 1, we let k be the repeated expression. We let k be the repeated expression. That's step number 1. Step 2, solve for k, standard form, factors, zero factor law, roots. That's what we mean by solve for k. We solve for k by doing what? We get the standard form, we use factors, or sometimes in some situation it might need a quadratic formula. You know, if we are factorizing, then zero factor law will follow, and then the roots for k. Step number 3, we substitute back. Where do we substitute back? We substitute back where we let k be equal to. So these k values are being found so that we can return them back in that expression that was equated with k. We substitute back, solve for x. That was our goal anyways, to solve for x, not to solve for k. But k is the way. So we call this the k way. I'm sure you know the brand, guys, the amazing sweet brand. K way. Repeated expression for different terms. That's when we use the k way. Repeated expressions which could potentially lead to x to the power 4, but we shortcut the process. We take that repeated expression, make it equal to k, makes life very simple. We solve for k, substitute back into the equation, then solve for x. This here is obviously having no solution because we say that the roots are non-real. Whenever we talk about the value of delta being negative, delta, remember delta is found underneath the square root here in the roots. Delta is negative, so we usually say that the roots are non-real. In other words, it means x has no solution. Whereas for the other equation, where we substituted the 2, we can solve this one and get the 2 solution. X is equal to -2 or x is equal to 1. Straightforward, right? I hope so. I hope you see that it's so straightforward. Let's move on to the next question. So basic, very straightforward. We would never miss these marks. We would never miss these marks. We would never miss these marks, right? Let's move on to this one. Would we ever miss the 6 glorious marks in this question? Would we? Would we? I hope not. I really hope not. I really hope not. Guys, these are giveaway marks. Remember, what did I say? The section of algebra, how many marks does it have? It has 45 plus minus 3 marks. Okay, please guys, these are chow marks. So in other words, the 45 marks for algebra should be marks that you should just take home, all of them. All of them. Don't play around with algebra and not take home all the marks. So let's try and take down this question. We are now entering into the world of fraction equations. The procedure, guys, for answering questions that have to do with fraction equations is very critical and important, and we need to make sure that we don't butcher any of the steps. So let's remind everyone in the platform, how do we solve for x in fraction equations? Step number 1. They usually say factorize the denominators if possible. All right, factorize the what? The denominators if possible. So if we look here, we look at x minus 3, no need to factorize because it's factorized already. 9 minus x squared. Can we factorize this? Well, it seems like we can, but before we even do that, let's look at the order of the expressions for each bracket. Starts with x, ends with constant. Starts with constant, ends with negative x squared. Starts with x, ends with constant. So we need to make this start with x and end with constant. And furthermore, if we can factorize it, we will go ahead and factorize it. So step number 1, factorize the denominator if possible. Let's go ahead and do that. X minus 3. 2 things. If we change the arrangement, that's all well and good, but this here has a negative sign. It would be sweet to change the arrangement. So what we do is we take out a negative sign and then we change the order of the terms so that x squared features first and negative 9c features second. Initially the x squared was negative. Now inside the bracket it is positive. Initially the 9 was positive. Now inside the bracket it is negative. In between we still have a negative sign anyways. So if we take out the negative, applying what we call the sign change rule. The sign change rule. This negative sign, if we distribute it back to the x squared, what's negative times x squared? We get this negative x squared back. What's negative times negative 9? We get this positive 9 back. Do you see that, grade 11s? You take this negative into the x squared, you get back the negative x squared. You take this negative back into the negative 9, negative times the negative is, we get back the positive 9. So we use the sign change rule, take out a negative, and then there's a relationship that we see between this positive and the negative sign. So what's the positive times the negative sign? We will see that in the next step that we write. But this is all part of factorizing the denominator. 2x over x minus 3. What is positive times a negative? We have two signs. We must resolve these signs. What is positive times a negative? That should give us one sign now that is negative in between these two fractions. Are we together? Then we have x minus 15. Then if we look at this x squared minus 9, isn't that a type of factorization that we can apply to this expression that is inside the bracket? What type of factorization can we apply here? This is a difference. These are two perfect squares. Variable raised to an even number, that's a perfect square. 9, the number 9 is a perfect square. So what type of factorization can we apply here? We can apply this kind of factorization in grade 11. So we say x and x, right? Because the square root of x squared is x, so we write x and x. Then the square root of 9 is 3, so we write 3 and 3. And since the sign is negative, that means we are going to write different signs. Negative constant means different signs inside the bracket. So one will be positive, the other one will be negative. Then we have x over x plus 3. I would say we have officially completed step 1. Factorize fully the denominators if possible. So I think we have just done factorizing the denominators of the equation fully. Step number 2. Write down the LCD and the accompanying restrictions. Write down the what? The LCD. The what? The lowest common denominator. So common, but lowest common denominator. So if we come down to the denominator here, x minus 3, all right, x plus 3, x minus 3, x plus 3. We can see, for instance, that for the common base with the highest exponent, the ones that are common, x minus 3 is a common base. It is a binomial but a monomial when it is in brackets. So this is a common bracket. It is shared with this x minus 3. So we only go and write down as our LCD x minus 3, and we write it once because x minus 3 is common. And both the exponent of this bracket is 1 and the exponent of this bracket is 1. We choose the common base with the what? With the highest exponent. So these have the same exponent. There's a 1 there, there would be a 1 there. So we take the common base with the lowest exponent, which means we write x minus 3, it's common, and we write it once. Then we have x plus 3 here and x plus 3. X plus 3 is common for two separate fractions. So that means we are going to include x plus 3 as a product to x minus 3 as also one of our LCDs. So these are our LCDs, x minus 3 and x plus 2 as a product. Then I said we write down the restrictions. What is the purpose of writing down a restriction? I want to ask you, grade 11, what is the purpose of writing down a restriction? Why do we write down a restriction? And is it important to write down a restriction? What is a restriction? Come on. You see now, this is where you guys need to talk to me. I wouldn't mind hearing a human voice in like join guest form and speaking to me. What is a restriction? Why do we write down the restriction? Is it even important to write down the restriction? What purpose does it serve? Kwazingubane says to determine roots which are not solutions of the equation. I love you, Kwazi. I love you so much. To determine roots which are not solutions of the equation. Those roots which are not solutions of the equations are verified. They are verified by the LCD. So we must look at this bracket first. This is x minus 3. What would happen, guys, if this denominator, for instance, had 0 in it? If this denominator had 0, what would that mean for this entire equation? It would mean that this entire equation is undefined. So the question is, what would make this denominator specifically 0? Which x value would be problematic, which would make this denominator 0? J Lacey, I see your answers. And this part is going to either confirm your answers. What I'm doing now, writing down the LCD and the restriction, will either confirm or crush your answers. I've noted your answers. I hope you guys can check what J Lacey has written down as the final answer. X is equal to -5 or x is equal to 3. What would make this denominator 0, guys? If x is what? What x value is dangerous that we can't have here? Because that will make this denominator 0. Thank you very much, Mazum. X here, if it is 3, then 3 minus 3 is 0. That is dangerous because that would make the entire fraction undefined. All right? So that means we cannot have x being what? Being 3. Because 3 minus 3 is 0. And for this denominator, if we have 3 here as the answer, 3 minus 3 is 0. So we cannot have x being what? Being 3. Writing the restriction because of the LCD. This aspect of the LCD. Are you with me, guys? This part is important and it is often forgotten and missed, and learners just simply don't even write down the restriction. And it becomes problematic. I'm going to show you very shortly why. Oh, Kwazi ngubani. Hey, wena Kwazi. You know, you Kwazi, you deserve something. In this expression, x plus 3, what can x not be? If we have what in this denominator for x, will this be 0? Yes, Catherine. X being minus 3, because minus 3 plus 3 gives me 0. So x cannot be what? Look at this bracket. X cannot be -3. These guys are what I call my restrictions. All right. And as Kwazi said earlier on, when I asked, why do we write down restrictions? Kwazi said it so beautifully. To determine the roots which are not solutions of the equation. Why? Because they will make the equation be undefined. And those values that will make the equation undefined, we have to exclude them from our answers in the event that we get answers. Lady P, please write down your restriction immediately after you write down your LCD. There is value when you do that. Now, I know most of you ask me, will I get marks for writing down the restriction? Lady P, it doesn't matter if you're going to get marks or not. Please write down the restriction, okay? Because please take note of my steps. I said step 1, factorize fully the denominator if possible. Step 2, write down the LCD and the restrictions. This is my LCD, this is my restriction. Step 3, now I'm moving away from this LCD and restriction thing. Hopefully you get my point. Step 3, we multiply each term by LCT. So now we are going to take this Mr. LCT. We are going to multiply each term by the LCT. Why? So that we can eliminate or get rid of the denominator in the equation. So if we take this x minus 3 into x plus 3, we multiply at the top with, I'm just going to write it here, guys, but you know, I don't see value in actually writing it out. I think you can use your head and actually see that if you are multiplying this with that, then in the denominator, who goes? Who leaves? Goodbye x minus 3, goodbye x minus 3. Who gets left behind? 2x, obviously, which is multiplied to x plus 3. That's who gets left behind. We do the same thing. We take the LCT, we multiply with this fraction in the numerator. Who gets left behind? No one, because they all going to disappear. X plus 3 is going to get cancelled with this x plus 3. X minus 3 is going to get cancelled with that x minus 3. So what gets left behind? Take note, guys, what gets left behind? This x minus 15 gets left behind in brackets. There's a negative sign. X minus 15 gets left behind in brackets. Okay? Hey, Mazuma. Mazuma, you are killing me. Thank you so much. That's a compliment and a half coming from another teacher. And I'm sure you're an exceptional teacher. I think it takes a mind such as yours, of course, accompanied with a generosity to like highlight such. So thank you so much. Not your therapist. I don't understand the SCR part, sir. Please explain. Not your therapist. Okay, I don't know if you got here later, but can I advise, guys, that when I leave a step or so, don't allow me to go to the next step and you are not sure. Please have the urgency to type quickly and tell me that, sir, you just explained this thing. I have no idea what you just said, so that I can actually make sure I explain that thing immediately, not later. Don't wait for me. So we have 2x over x minus 3 plus x minus 15 over 9 minus x squared is equal to x over x plus 3. And the first thing I said to you is that step 1, in fraction equations, it's always advised to factorize fully the denominators if possible. Currently, we have x minus 3 in the fraction denominator, the first fraction. 9 minus x squared and x plus 3. This x minus 3 and this x plus 3 are already factored. There's no further factorization you can do with this and that. 9 minus x squared, on the other hand, needs to be first. We need to change the order of the terms because the constant is first and the x squared term is last, and it's just not giving. So what we do is we do what? We apply a procedure that we call the sign change rule. Why? Because in between these two terms there's a minus sign. If there's a minus sign in between the two terms, and I can see my term that is supposed to be first is last, and the one that is supposed to be last is first. You know, it's like in the Bible, the first shall be last and the last shall be first. So the term that's supposed to be first is actually last. Okay, in between the and in between there's a minus sign. The thing is that in between there must be a what? A minus sign. What we do is we take out a negative sign. That's what we do. We're applying what we call the SCR, which we call the sign change rule. Take out a minus sign. You open the brackets. You then change the order. You put x squared first. It's no longer negative, but it's positive now. Then you put the 9 last. It's no longer positive, but it is negative. Why do you do that? Because look, if you take the negative sign back, negative times x squared gives you back what you had originally. Negative times negative, when you distribute there, it gives you back the positive 9 that you had originally. But now, since you took out a negative sign, this negative sign gets multiplied, or we need to resolve, because there's two signs which are competing for my affection in the equation. We multiply these two. What's positive times a negative? Eventually we resolve the sign and the sign becomes negative. But we have now x squared minus 9 in the denominator. The order is acceptable. Then we can see that x squared minus 9 can be factorized, because this is a difference of two perfect squares. When you factorize a difference of two perfect squares, we open two brackets, x, because the square root of x squared is x, and then since 9 also is a perfect square, the square root of 9 is 3 and 3, and then because the sign is negative, we always know that the sign for both brackets will be different, because minus the negative sign for a last term or constant term means that you are going to have two different signs in your bracket. Hopefully the procedure now makes sense and you understand why the SCR. You need to confirm for me in the comment section that you've understood me. If not, my leader, then it means you need to find someone else. I'm a terrible teacher, and I wouldn't have you stay any longer in this thing. Yes, Ivile. That's why we call it the sign change rule. When we put terms that originally were not in the right order, because the variable is last and the constant is first, and we want to change the order so that it complements the expressions in the denominator that we have for the other fractions. We take the sign change rule says we take out a negative sign, you see, and then we write the order properly thereafter. Because taking out a negative sign, what does it actually do? This negative sign distributed back gives us positive x squared back, and this negative sign multiplied the positive 9 back. I hope that makes sense. Blue, if this was 9 plus x squared, then we wouldn't have to apply the sign change rule. Why? Because my Mr. Blue, 9 plus x squared is the same thing as x squared plus 9. So changing the order just like that don't matter. No sign change rule having to be taken. You just simply change around the two terms, because 1 plus 2, is the same thing as 2 plus 1. What is 1 plus 2? It is 3. What is 2 plus 1? It is 3. That's why in grade 8 and 9 you learned the following, that addition is commutative. What does that mean? It means the order in which you place numbers when there's addition don't matter. Okay? But with subtraction, it's a different story. 1 minus 2 is equal to negative 1, whereas 2 minus 1 is 1. Are these things the same? No, they are not. So that is why we apply the sign change rule when it comes to having a minus sign in between the terms, because we cannot change order unless we take out a negative sign in order for things to be the same when there's a minus in between. When there's a plus, don't matter. In actual fact, we don't have a problem. But if we have a minus, sign change rule needs to be applied. I hope it makes sense. Blue. Okay. Now, after that, we write down the LCD and the restriction, and then you remember I said LCD and restriction, and the restriction, even if you didn't think it's important in the past, now I'm sure you see it is. Then step 3, multiply each term by the LCDY to eliminate or get rid of the denominators. So I take the LCD, I'm going to just play the cancellation game. Who gets cancelled? You and you. We don't like you anymore. Who gets left behind? X plus 3 in the numerator. So we say 2x times x plus 3. Now some people who may be looking at this will be like, but sir, why you had x plus 3 multiplied by 2x? Now why are you writing 2x multiplied by x plus 3. It goes back to this thing. So addition is commutative, so is multiplication, guys. What's 1 times 2? It is 2. What's 2 times 1? It is 2. So that's why in grade 8 and 9 you learned that addition and multiplication are both what? Commutative. The order don't matter. The order don't matter with addition and multiplication. Don't matter with addition and multiplication. Don't matter because you get the same answer, you know. Don't matter. I hope it makes sense, guys. I hope you understand. Okay, so 2x into x plus 3 is fine. Minus, you have a binomial. Please put the binomial in brackets. In actual fact, I would advise that from the get-go, if ever you find that in your numerator you have a binomial, 2 terms or 3 terms, they are in the numerator, do yourself a favor and immediately put brackets around those. This one is already a monomial, no brackets needed. This is already a monomial, no brackets needed. But if this is a binomial, trinomial, meaning it's 2 terms, 3 terms, 4 terms, put brackets immediately. So after the cancellation, when you've multiplied with the LCD in the numerator, x plus 3 gets cancelled, x minus 3 gets cancelled, you are left with 1 that is multiplied with this thing. So you put brackets there. Okay? Equal to, take LCD, multiply here at the top, who gets cancelled? X plus 3, who gets left behind? Let me wait and see who gets left behind for x at the top, because obviously x plus 3 is getting cancelled. So who gets left behind? There at the top with x. Who gets left behind? Thank you, Kwazinguban. Thank you, Amkhalang. You guys are 100%. He gets left behind, x minus 3. Their relationship between the x and the x minus 3 is one of multiplication. Now, step 4. Let us multiply out, add and subtract like terms, and hopefully get to what? To standard form. Multiply out, add and subtract so that we can get where? To standard form. Okay, so I think we're going to now apply Mr. Distributive Law. For instance, here 2x into x, 2x into 3. Here as well, minus into x, minus into negative 15. Too many times learners just simply don't put the bracket around x minus 15. What happens is that they take this negative sign to mean that it's just next to x. Okay, but then they don't put it next to what? Next to negative. Yeah, they don't actually take it into consideration that negative needs to go to negative 15 as well. So they leave that negative next to x alone, and then the negative 15 stays negative 15. So that is a dangerous thing that can happen if you omit to put brackets. So that's why I'm saying in the numerator, if you have 2 terms, 3 terms, please put brackets around them. Okay, then we are going to distribute that with that as well, and then get it to standard form. So what's 2x times x? 2x squared. Hopefully we all understand that. We multiply the sign, we multiply the number 2 times 1, which is 2, we multiply the letter x times x. Bases are the same, we keep the base, we add the exponents. The 1, which is the Holy Ghost, which you cannot see, 1 plus 1 gives us 2 as an exponent. Then we say 2x times 3, 2 times 3, positive times a positive is positive, 2 times 3 is 6, and then the x immediately next door. Take the negative, guys, very important this part. Most learners lose marks because they don't distribute the negative sign even to the negative 15. Negative times x, negative x. Negative times negative 15, positive 15. Okay, do you see how subtle marks can just leave? X times x, that gives us x squared, and then x times negative 3, that's negative 3x. Transpose. Okay, so we multiply, add, transpose, so that we can all get this to be in standard form. So we have 2x squared. Let's take the like term x squared minus x squared plus 6x minus x. Take the negative 3x plus 3x when it crosses over plus 15, which is all equal to 0. I think standard form is very close. 2x squared minus x squared, that gives us x squared. 6x minus x plus 3x, that's 6x plus 3x. We know that when we add like terms, we keep the variable x as it is. Then we add and subtract the coefficients. So this is 6 minus 1, which is 5, 5 plus 3, which is plus 8. And then lastly, we have 15. Standard form has been achieved. Hoorah, 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 which means I did all my multiplication, my addition, my subtraction, my transposing 100% correct. I put brackets. I think this is something I'm going to have to make sure here. Put brackets in the numerator where there are binomials. Put brackets around binomials, trinomials, and any other polynomials, and meaning any terms that you see in the numerator that are 2 or more. Put brackets, like we put brackets around x minus 15. You see, which helped us out a lot in distributing the negative and making sure that our terms are 100% correct. Then we check. Then here we are ready now. Okay. Oh shit, man, I'm sorry. I can imagine you guys must be pushed. Please guys, feel free to leave the live. Remember, I do post the video of the live video on my YouTube channel. I'll try and save it and upload it there. You can watch it or watch the rest at your own time if you feel the need. Some of you may not even be needing this revision. You know, you're just sort of like here because you're like, let's at least just have ourselves here, you know, for the sake of this guy. He needs company. So you may not need this really. So feel free to leave if you need to, you know, because this might all be repetition for you. I'll be ending at 12 exactly. All right. That's what I had promised these guys. So when we factorize after standard form, we factorize. So that means x. We know that plus for constant terms means same signs. Same signs according to who? According to the positive number of the x term. So that means we're going to have plus, that I know for a fact. And then the factors of 15. When we multiply, we get 15. When we add, we get 8. Okay, that means we have 5 and 3. Okay, so those are our factors. Then after factors, okay, all right, Clivia. After factors, we then write what? We apply the zero factor law. So x plus 5 now obviously is equal to 0, or x plus 3 is equal to 0. That is our zero factor law. Okay, and then last but not least, 7. We have now to write our roots. Our roots are what? X is equal to negative 5 or x is equal to negative 3. But after doing all of that, we check our roots against the restrictions. And then you guys ask me this question. Do we have to check? Do we have to write down the restrictions? Remember, what did we say are our restrictions? The last step we do, we check our roots that we got. We check them against the restrictions. There are my restrictions. I look at them one more time. I had said x cannot be 3 or x cannot be negative 3. So I go to my answers. I got x is equal to negative 5. We can accept this one. But remember, according to my restrictions, we said x cannot be negative 3 because if we take the negative 3 and substitute, for instance, in this fraction, in this denominator, this would lead to a fraction that is undefined. So therefore, we then have to say x cannot be negative 3 as per our restriction. Do you see now, guys, why it's so important to write down your restrictions? Because the last step in these types of questions with fraction equations requires us to check our roots against our restrictions. If one of the restrictions is not something that we should be including in our answer, then we make sure that we exclude it from the answer. Make sense? Guys, I hope you gained something, even though this was a bit long. Guys, these are exam type questions. The person who said to me, then move on to exam type questions, this is actually an exam question paper. Okay? Exam question paper, this one. So these are exam type questions. Okay, these are not just textbook questions. They may probably be similar to textbook questions as they sometimes ought to be, but these are definitely exam type. Okay. So there is no need. Yes, there's no need to substitute the answers. The need is to write down the roots first. All right. And then after writing down the roots, you must check your answers against your restrictions. So that's why you have to have restrictions. So the person who asked me, do I have to write down the restrictions? I suggest you do, so that when you come here at the end, you can always go and check against your restrictions which answers you basically have to exclude. So I would get all my marks there, no doubt. Let's move on to the next question. 1.1.5. Okay. 1 minus 4x underneath the square root. This minus 1 is outside and it's equal to 2x. What do we call these kinds of equations? We call them surd equations. So what did we say? The square root of 1 minus 4x minus 1 is equal to 2x. This is a surd equation. Okay. So 1 minus 4x underneath the square root minus 1 is equal to 2x, and the thing is saying solve for x. So what is step 1 of all surd equation questions that we answer? Firstly, we need to isolate the surd. What does it mean to isolate the surd? It's like you, maybe in your room, you are all alone right now. We need to make the surd, meaning the expression underneath the square root. The one that has the square root needs to be made alone. So let's do that. Let's practice what we are saying. Take the negative 1 over, we have 2x plus 1. This is the surd isolated. We have 2x plus 1. That leads us to step 2. We square. What do we square, guys? We square both sides. Square both sides. Guys, I see you guys are, you see, look, question papers usually have instructions, information. There is the questions. Okay, there is the questions. You know what here? Please, guys, don't matter what here. Look. Nature of roots is coming up. You see? Exponents. Look, you see? Look at this. 150 marks total. You see? Hi, guys. This one was focusing primarily, it was a question paper focusing primarily on these first few topics that I want to cover, you know, up until exponents and surds with nature of roots. So it's coming up. I'll cover those things. 1 minus 4x under the square is equal to 2x plus 1. Okay. On Tatile Makone, this is grade 11. They are not done with mathematics. Maybe you are in grade 12 and you are done, but this is grade 11. And you know that things that you do in grade 11 are done in grade 12. Okay, then we square both sides. So let's do that. When we square both sides, what happens to the square root? It disappears. We have 1 minus 4x on the left. Here, let's not make the mistake of wanting to square the first term and the last term and we think that's it. When there's a plus and the minus sign, we open 2 brackets and then we foil. So our foiling, what does it lead to? Okay, I'm hoping to, Kristen, 4x squared, you square the first term, you square the last term, you multiply the 2 terms. 2x times 1 gives you 2x, and then you multiply that by 2. That gives you the middle term, which is 4x. Okay, that's like a quick way of actually foiling when you have a binomial squared. Listen to me. What do? We square the first term. There it is. It's 4x squared. You square the last term. There it is, positive 1. Then you multiply 2x and 1, which gives you 2x, and then you times that by 2. That gives you 4x for your middle term. Do you see how quick that is? Guys, leave me alone. Leave me alone. You know, 4x squared plus 4x. I take Mr. Negative 4x, he crosses over, he becomes 4x as well, plus 1, which is positive here. I take this one over, it becomes minus 1. I leave the 0 that side. You see, I'm transposing to this side because I can see the coefficient of x squared is already positive. I don't want to be wasting my time and taking this side becomes negative, you know, all of that mumbo jumbo. Okay, right? I hope it makes sense. 4x squared, we have 4x, that 4x, negative 4x became positive 4x. So now we have 4x squared plus 8x. What's 1 minus 1? That gives us 0. So in other words, we have 0 is equal to, now remember guys, we now have to take out a highest common factor because there is one. And the highest common factor we have here, if you remember what I said earlier on, I said if the highest common factor is just a number, we divide all the terms with that highest common factor to simplify the equation. But if the highest common factor is a number with a variable, we take out the highest common factor. We do not divide at all. So look, I'm going to apply what I just said. Here we are going to take out a highest common factor, which is 4x. Then what are we left with? X plus, what's 4x times 2x? Plus 2. Okay. I hope that makes sense. Then after standard form factors, then we apply the what? The zero factor law. 4x is equal to 0 or x plus 2 is 0. Then we solve for each independent answer. That means 4x, we divide by 4 both sides, x is equal to 0 or x is equal to negative 2. Okay. So 3, after squaring both sides, we get our equation to standard form. Okay, so we simplify first the equation, then we get it to standard form, then we factorize. If factorization is not possible, we can use the quadratic formula. 5, after factorizing, we apply the zero factor law. 6, we get our roots, and then number 7, check. For third equations, that is where you have to definitely check your values of x that you got. So we must take this 0, go back to the original equation. Take 0, put it here. 1 minus 4 times 0. 4 times 0 is 0. And then 1 minus 0 gives you 1 underneath the square root. So we have the square root of 1, which is 1. What's 1 minus 1? We have 0 on the left. Take the same 0, we multiply by 2. We get 0 on the right. So that means x is equal to 0 is an answer that we accept. Take negative 2, do the same thing. Negative 2, we multiply by negative 4 because we substituted here. So that's negative 4 times negative 2, which gives us positive 8. 8 plus 1 is 9. And the square root of 9 is 3. Guys, you can use your calculator to quickly check. Don't have to necessarily do all of this. So 3 minus 1 gives us a number 2 for our left. Let's come and take the same negative 2 and multiply it with this positive 2. So 2 times negative 2 gives us negative 4. 2 cannot be negative 4. So that means x cannot be negative 2. X is equal to 0 alone. That is the only answer we have in that third equation. Is it coming back, guys? Is it coming back to us? Step 1, isolate the third. Third is isolated, negative 1 has been transposed. Step number 2, square both sides. Squaring both sides eliminates the square root. We have 1 minus 4x. If we square the binomial, we must make sure we square the first term, square the last term, multiply the 2 terms in the bracket, and times by 2 to get the middle term. We have 3 terms that's supposed to come about from the squaring of the binomial. We then simplify and add and subtract like terms, and then we get to standard form. 4x squared plus 8x is equal to 0. We then factorize. If we cannot factorize, we could use the quadratic formula. That would work as well. After factorizing, we apply the zero factor law. 4x is equal to 0, x plus 2 is equal to 0. And then after that, we do what? We get the roots. After getting the roots, we check to see when we substitute 0 into the original equation, does it actually give me the same answer on the left and the right? And when I substitute -2, do I get the same answer on the left and the right? And what I found here is that x works, x is equal to 0 works, but x is equal to -2 don't work at all. So therefore we do not include it. This was the question. 6 marks. Did we get all of our 6 marks? Most definitely. 1.1.6. 3 marks. Inequality. Thank you so much, Robert, for that beautiful gift. I really appreciate it. The first of the night. I love you so much as well. Thank you so much for being so generous and kind. 1 minus 4x into x minus 4 less than or equal to 0. So we have 2 inequalities that we are going to be solving. Let's first look at 1.1.6 and then we'll look at 1.1.7. I'll do functions tomorrow, Ivile. Same time tomorrow, 9 p.m. We'll do another live session. I'll do the next big chunk of marks because remember I said general algebra for grade 11 is 45 plus minus 3 marks. And then of course function is also 45 plus minus 3 marks. So those are sections we need to really look at, okay? Oh, you're writing tomorrow, Christine. Oh, sorry, man. That is sad. That is so sad. I actually, sorry, in my Maths Gamers group on WhatsApp, they had indicated that they are writing only on Friday. So I'm guessing you're probably in a different province and you guys are writing tomorrow, grade 11. That's insane. That is insane. Remember, this is a general question paper. It's a general question paper that has basically, like I said, yes, I do. You're writing paper? Yo, Christine, that's like back to back. Yeah. Which province are you in, Christine? Yo, wow. Talk about back to back writing. Your province is merciless. Yo. Oh dang, yeah, you guys don't mess around, do you? Okay, yeah, but that surely is not applicable to all Gauteng schools. Is that like specifically in your area or what? Like, because I know Gauteng, there's like Joburg North, there's this, so probably like it's a different district that's writing like specifically paper 2, and other districts will write on at a different time. I wonder, or is it the entire province? Why didn't my Gauteng students speak? 1 minus 4x into x minus 4 less than or equal to 0. So guys, first thing that you notice, look at the brackets. 1 minus 4x, the order here is not make sure because the x term is negative, okay, and it is not first. Okay, I see you. Okay, I get you. Then this second bracket, this is x minus 4. Okay, this one is x minus 4. So this order is fine. There's 0 on the other side. The inequality is less than or equal to 0, but you see the order, this one is not make sure. So what we do for this bracket alone is we apply that procedure I spoke about. Okay, if there's a 0 on this side, because if there was no 0, we would actually distribute and get it into standard form. But you see there is already 0, so there's no need for distribution. We can apply the sign change rule for this bracket. Okay, we can apply the sign change rule. So we'll take out a negative sign for that bracket and then write the order for x minus 1. I hope this SCR procedure now you get it quite well. Then of course x minus 4 is fine. Okay, and it's still less than or equal to 0. So if we take the negative sign back, we get that back. So it's not like anything is lost. But now that negative sign needs to go. It has to completely disappear because it's a linear inequality. So what we do is we divide both sides by a -1. When that happens, because all of these are multiplied, negative is multiplied to this bracket, multiplied to this bracket. If we divide by a -1 on both sides, what happens to the inequality sign is that it changes direction. That negative sign has disappeared. Okay, why, guys, did we use the sign change rule? Because this bracket has a constant followed by the x term. Typically, we always want the x term first and the constant. If the order was okay here and it was like an x term followed by a constant term and that x term was positive, then we wouldn't have applied the sign change rule. But because the x term is negative, we know that it means we need to take out the negative sign applying the sign change rule. Then we divide, okay? Divide both sides by negative. And we know with inequalities, whenever we divide by a negative specifically, when you divide both sides by a negative, this inequality sign changes direction. So that's what happened here. The inequality sign was less than or equal to 0. Now it's greater than or equal to 0. Then after that, after our factors are sorted, as you can see, these are our factors, we then need to write down our critical values. Okay, and if you remember, our critical values are also referred to as our roots. So that means what would be the root typically if this was an equation? That means x would be equal to 1 over 4. So we write down that this is a critical value 1 over 4, or x is equal to positive 4. These are our critical values, 1 over 4 and 4. I hope this makes sense, guys. 1 over 4 and 4. Those are our what? Our critical values. Then from there, what do? We represent those critical values on a number line with a graphical representation. So if we look at this particular step, this graphical representation I see here, okay, the x terms are positive. If we would multiply, we would have a value that is positive, which means it's a smiling face. So the graphical representation is a smiling face because of that fact. Then we have a critical value that is the smallest to start with, which is 1 over 4. Between 1 over 4 and 4, 1 over 4 is the smallest, 4 is the biggest. We write 1 over 4 this side, okay? And then this side we have 4. Okay, I hope that makes sense. Then with the 1 over 4 and the 4 on this side, we can then come here and interpret using this graph what this inequality sign means. So if we say 4x minus 1 into x minus 4 is greater than 0, what do we mean by greater than 0? We mean above the x-axis. Okay. What does greater than 0 mean? It means above the x-axis. Exactly, Ivile, where y is positive. Guys, if you look at the Cartesian plane, the y-axis, this is the x-axis. Above this axis, these are positive y values. So y is positive, guys. It's greater than 0 in this area above the x-axis. But y is less than 0, or y is negative, guys, below the what? The x-axis. I hope it makes sense. Greater than 0 above the x-axis, less than 0 below the x-axis. So when we have greater than 0, we always understand that to mean above the x-axis. So let's check from our graph, where is the function above the x-axis? It is above the x-axis in this region and also in this region. Okay, What about this region do we know? This is where x is less. This area here, 1 over 4 is the critical value, right? It's here. But if we are talking about the function above at the x-axis, it's always above where x is less than 1 over 4. Or it is also above after 4, meaning when x is greater than 4, the function you can see is above the what? The x-axis. So we say x is greater than 4. But that is not the only thing that we see here. It's not only greater than 0, meaning above the x-axis, where y is positive. We also know, according to this equal sign that is here, it is also on the x-axis. It is what? It is on the x-axis. So where is the function on the x-axis? It is on the x-axis where x is equal to 1 over 4. It is also on the x-axis where x is equal to 4. So that is why our answer is x is less than or equal to 1 over 4, this side, or x is greater than or equal to 4, that side. That is the full answer. And for this part, there are 2 designated marks that you get for writing the answer. Okay, I think in this question paper, they actually did not allocate sufficient or adequate marks. We should have been getting 4 marks, a little bit more than just 3 marks for that question. Okay, let's come here now. Okay, 4x squared is less than or equal to 1. So let's quickly do this one. 4x squared is less than or equal to 1. Step number 1, we always need to write the equation in standard form. So 4x squared minus 1 is less than or equal to 0. 2, our factors. So in this case, we can see a difference of what? 2 perfect squares. So we open 2 brackets. We say less than or equal to 0. We have the square root of 4 is 2. The square root of x squared is x. The square root of 1 is 1. And then negative means plus, then minus. Factorization has been done. Then step 3, critical values. CV, x is equal to, when we get the actual roots, if it was an equation, it's negative half, or x is equal to positive half. These are our 2 basic critical values. Then step number 4, graph on number line. We draw a x-axis, concave up or up function. We look at the interpretation at this stage before the critical values. We have less than. What does less than mean? Below the what? The x-axis. Remember, we said greater than means above. So less than means below the x-axis. This is where y is what? Negative. Where is the function below? We're going to check that out. What does equal mean? On the x-axis. Okay, so where are the critical values? Negative half and positive half. Smallest, biggest. Then where is below the x-axis? We are operating here now. Okay, where is on the x-axis? It is exactly on the critical values. So how do we write this answer? X is in the middle. X is greater than or equal, as we read it like this, x is greater than or equal to negative half. Think about it. X is greater than or equal to negative half, but x is less than or equal to half. X is less than but also equal to half. This is our answer. I know some people usually write this answer in interval notation, negative half to half, and they use square brackets because the answers are also, the critical values are also included. So this is another way that you would express this very same answer if you wanted to, and not write it in inequality form. You could write it this way, or you could write it that way. It's really up to you how you do it. Okay, and remember this last part, 2 marks, guys. Okay, they could give you a mark for standard form, give you a mark for factors and critical values, but they will always give you 2 marks there for your answer. Please make sure that you do write your final answer. All right, so that's why, for instance, I say this is a BB situation. When you have a below the x-axis, the answer is always going to be between the 2 CVs. But if it's above the x-axis, then it means the answer will be away from the CVs. That's why I call this AA, and then I call this BB. So we have AA, above and away, and then BB, below and between. Okay, that's how I remember it. Makes sense for me, and it helps me a lot so that I don't forget critical values when the need is there. Look at this exam type question. If x is equal to 1 and x is equal to -4, are roots, okay, of the equation. No problem, no problem, Emken, that's okay. If x is equal to 1 and x is equal to -4 are roots of the equation 3x squared plus bx plus c is equal to 0. Determine the values of b and c. Again, if x is equal to 1 and x is equal to -4 are roots of the equation, determine the value of b. B is the coefficient of x, and c is the constant. Okay, now the essence of this question lies in understanding what is a root. We did say that a root is a solution of the equation. We have 2 of them. We are saying x is equal to 1 and x is equal to -4 are both what? Roots of the equation. And they are saying determine the value of b and c for 4 marks. How would we go about answering that question? Now, if x is equal to 1 is a root, then it means the following. Where x is equal to 1, we can substitute that into 3x squared plus bx plus c is equal to 0. So let's do that and see what we get. 3 into 1 squared plus b into 1 plus c is equal to 0. What does that lead us to? Lead us to 3 times 1 squared is 3 plus b plus c is equal to 0. So we have an equation here. B plus c is equal to -3. We will say that is equation 1. Let's take the second root, which is x is equal to what? -4. We're going to do the same thing, substitute it into this equation. That means 3 into 4 squared plus b into 4 plus c is equal to 0. Then we are going to write this equation also in terms of b and c. 4 squared is 16 times 3 is 48. What's b times 4? 4b plus c. Then what do we have? 4b plus c is equal to 48. That is equation 2. -4, sir. All right. Error from my side, is it? Yes, -4. Okay, sorry, that was -4. Thank you so much, Evie. Okay, I love it when you guys are able to catch my errors. I hope you'll catch yours when you write your exam. Very key. So 48 minus, sorry, this plus should actually be minus 4b. So -4b plus c is equal to 48. Thank you so much for that, Evie. That 48, when you transpose it, becomes -48. -4b plus c. That 3 became -3. All right. Then what can we do here? We have 2 linear equations. We can solve them simultaneously. This is taking us back to what? To grade 10, where we can solve for b and c using what? Either we can use the substitution method or we can use the elimination method. Okay, substitution becomes very predominantly famous in grade 12, 11 and 12. So let's make C the subject and take B over, or we can make B the subject and take C over. Very good, Ivile. We isolate the first equation. So we can say C is equal to -3, for instance, minus B. We make that equation 3. Then we can take equation 3 and substitute it into equation 2. So if we do that, that means everywhere where we see this C, we are going to substitute this expression -3 minus B. Everywhere where there's C, we're going to substitute this expression. So let's come and write down equation 2. Minus 4B plus, in the place of C, we write -3 minus B, which is equal to -48. This is the equation. Minus 4B, in the place of C, we write -3 minus B in brackets, is equal to -48. Let's solve now for B. Positive times a negative is equal to -48. Then, of course, guys, we isolate the B's. We're gonna get -5B on the left-hand side, -4, you see? And then we are saying -48. We take the -3 over plus 3. That gives us -45. So -5B is equal to -45. We divide both sides by -5. We get B is equal to what? 9. Positive 9. So that means this B is 9. Now we need C. So we are going to go back to where we made C the subject for equation 3 and substitute B, which is 9. -3 minus 9 is going to give us -12. So we're going to say C is equal to -3 minus 9. We get C, which is -12. What did they want from us? Us to determine the value of B and C. This is one way of doing this question, and I hope you understand. Let me go back and reread it. Please, guys, that's why I said in the beginning, what are roots? Roots are the solutions of the equation. So if x is equal to 1 and x is equal to -2 are -4 are roots of the equation. 3x squared plus bx plus c is equal to 0. Determine the value of b and c. So having substituted this and gotten an equation in terms of b and c, you can see it's only b and c that are going to get left behind if I substitute 1. And if I do the same thing, I substitute -4, I'm going to be left with b and c. So you can even see, even before you do the question, that, oh, this is going to be a matter of solving two equations simultaneously that are linear, which you basically learned in grade 10. So this is just a question to sort of like test your mathematical gymnastics, if you want, and your fluency, to see if your algebraic skills are on par. Then what is another way we could have done this question? Second way you could have answered the same question is you could have said, look, if they say x is equal to 1, x is equal to -4 are roots of this equation. Let's just think for a moment. And work backwards. X is equal to 1, x is equal to -4. Look at this. Let's work backwards, guys. What does x is equal to 1 look like as a factor? It looks like this. You take the 1 over, you have x minus 1 is equal to 0. What does x is equal to -4 look like as a factor? You have x plus 4 is equal to 0. Okay, good evening. So sorry, someone asked me if I do integration tertiary level. Yeah, integration is done tertiary level, except you are doing IEB. I believe IEB does do a level of integration. Okay. No, I've never done integration. In my live sessions, I purely stick to CAPS and IEB to an extent, not to integration level. So yeah, you might have not seen me. I think you saw someone else do that. Thanks for thinking that I do integration, but no, I don't. Okay, these are things that are still in the developmental stage. I still really want to kind of help learners in high school. So for now, it's really grade 8 to 12. X minus 1 is equal to 0, x plus 4 is equal to 0. That is the factors. So we could say x minus 1 into x plus 4 is equal to 0. Do you see this, guys? We're working in reverse. from the equations to so from the roots to the zero factor law to the factors. Now I'm going back to the standard form. Look at this. X times x, I get x squared. X times 4 is 4x. Minus 1 times x, minus x. Minus 1 times positive 4, negative 4. That's all equal to 0. Then I say x squared plus 3x minus 4 is equal to 0. Now I'm sure most of you are like saying, but sir, look at this. This starts with 3. Yours starts with 1. How do I fix the situation of it starting with 3? Well, you know what? I'm going to multiply the equation that I have there by 3. What I do on the left, I'm going to do on the right. So I'm going to say 3 into x squared plus 3x minus 4 is equal to 0 times 3. When I multiply by 3 on the left, but remember when I multiply by 3, it means I'm going to multiply by 3 for all terms. So let's distribute this 3. 3 times x squared, 3x squared. 3 times 3x plus 9x. 3 times negative 4, negative 12 is equal to what? 0. I think we have our b. There it is. B is equal to 9. I think we have our c as well. Negative 12. Wasn't that the values that we had? Yeah, it seems like it, eh? So this is a second way of doing the same question, just with a different thought process in mind. Now, do you see why, guys, the procedure? Because we understand the forward movement of the procedure. Standard form, factors, zero factor, lower roots. But now, working backwards, different story. In this situation, I could work backwards so that I can get the values of B and C. Okay, so that's what I call true gymnastics. Okay, you see now I'm entering into that zone of exam type. Look at this is another exam common. Okay, look at this one. Solve for x in terms of P. All right, I'm not going to really do this question, but when they say solve for x in terms of something else, then it means that in your answer, they don't want you to have a value that is a number. They actually want you to have a value that has a variable. In terms of x means that your expression, which will be your answer, is going to have p in it. All right, it's going to have p in it. Right. So I'm not going to do all of that, guys. I'm just gonna kind of show you that there's nothing much to the question but applying the procedure. So they are saying solve for x in terms of p. So what I'm going to write first, I'm going to make sure this equation is in standard form. What's x times 15x? 15x squared. What's x times negative p? It's negative xp. And then the 6p squared you're going to transpose to become negative 6p squared equal to 0. Right? So if I look at this now, I'm like, okay, in terms of p, let's just say we're going to use the quadratic formula. My a value is 15, b is equal to negative p. Now, please take note, coefficient of x is a negative p. So I write negative p as my b, and your c is negative 6p squared. All right, then I'm going to just simply use the what? The quadratic formula. Okay, and then what's negative p? Negative into negative p, p squared, negative p, the whole thing squared, a 15 times c, which is negative 6p squared, over what? Over 2 times 15. You see? So my roots or my solutions are definitely in terms of p. But what I'm going to do is I'm just going to make sure that I simplify this side as far as possible so that my roots in terms of p are simplified. They are not left just, untidy. So what's negative times the negative? Let's simplify that at least, that's positive. surely that should warrant us some marks, into, what's negative p, the whole thing squared? We have p squared, because a square and even exponent to a negative sign will make it positive, and then p is p squared. Then we have 4 times 15, that is 60, negative 60, and then negative 60 times 6, that is positive 360. Ne? Positive 360 p squared. Again, positive 360 p squared over what, guys? Over 30. We're not done. Inside here we have like terms, because p squared plus 360 p squared, these are like terms. The variable is p squared, it's a like term, so we are going to say 361 p squared over what? Over 30. Now I believe 361, my question is, you know, most with a 361 p squared, is 361 the square root of 361? Do we get an actual numerical value? Because if we do, then I'd like to find out what is the square root of 361, if there is a value. Is there a numerical value that we get, or do we get decimals? Because if we get decimals for just 300, we can separate the square root, because 361 and p squared are multiplied. So we can get 300, the square root of 361 alone. The square root of p squared is going to be p, but I just want to establish, do we get a numerical value that is a decimal, or is there a number, an integer that comes about by taking the square root of 361? If not, then I'll leave it. So can you please repeat from 360 to 361? Catherine, p squared. This is p squared. Are we good? This is plus 360 p squared. Aren't these like terms? I want to ask you that, Christine. Are these like terms? Catherine, sorry. You see, I'm saying Christine. Oh, Christine was answering Faith. Yes, they are. So what is p squared plus 360 p squared? Don't forget like terms now all of a sudden. Don't go cold on yourself now. What's p squared plus 360 p squared? When you are adding like terms, you keep the variable, which is p squared. You add the coefficient. This is 1 plus 360. What's 1 plus 360? The coefficient is going to be 361. Now, what I want to establish from you guys, the square root of a coefficient in a variable can be written separately. Is 361 the square root of 361? Is there a natural number that comes about with the square root of 361 alone? If not, then I want to write down the answer. If it does. If not, then I guess we have to leave our answer like that. Okay? And then for the sake of simplification, okay, someone needs to tell me, square root of 361? It's 19. Okay, do you see that, guys? So that means p plus minus the square root of 361 times the square root of p squared. I am applying my third multiplication laws, because the third multiplication laws says the square root of a times b is equal to the square root of a times the square root of b. So for multiplication and division, we can split the what? The root. But for addition and subtraction, we cannot split the root. We cannot split the root for addition and subtraction. That's something very important. So we can now say that p plus minus 19p, the square root of p squared is p as well, right? Over 30. So after all is said and done, it means we can say p plus 19p, that's 20p over 30, or p minus 19p, that's minus 18p over 30. Because look, P and P are like terms. Are you together? There, so that's x is equal to, or x is equal to. Finally, we can simplify this further. What's 20 divided by 30? It's 2 over 3p. That's x. Or 18 divided by 30. That is basically what? 3 over 5. Negative 3 over 5p. Those are our answer in terms. You see, x is in terms of p. Wasn't that an interesting question? This is what I call exam type, okay, guys. Okay, you guys know how to solve for x, but all of a sudden they say solve for x in terms of another variable, and they specifically tell you where p cannot be 0. So there it is, guys. 2p over 3, or x is equal to negative 3 over 5p. That is my answers. Okay, that is my answers. And I hope you can follow through with how I used the quadratic formula to be able to maneuver and get to where I was able to eventually get. Okay, look at this one. This question tends to really feature a lot sometimes in certain questions, and learners tend to have some problems with doing it. Look at this. If x plus 1 over x is equal to root 3, determine without solving the equation the value of x squared plus 1 over x squared. I repeat, if x plus 1 over x is equal to the square root of 3, determine without solving the equation the value of x squared plus 1 over x squared. So I write down for this particular question, x plus 1 over x is equal to root 3. Okay, and I can see what they want from me is the value of x squared plus 1 over x squared. So check me do this. I am going to take the left hand side and square it and the right hand side together. When I do that, what happens? Okay, remember when I square a binomial term, what did I say we do? We square the first term for the first term. We square the last term for the last term. And then we multiply these two to get the middle term, and then we multiply these two. So that means I'm going to multiply x times 1 over x, which will give me what? 1. The x in the numerator, the x in the denominator, they cancel each other. And then I get 1 times 1, which is 1. And then after getting 1, what do I do? I multiply that whatever I got by 2, which gives me 2. So that means my middle term is 2. I repeat, square the first term, x squared. Square the last term, which means you square 1, which is 1. You square the denominator, which is x squared. Then when you want to get the middle term, you multiply these two together. 1 times 1 over x gives us 1. Then you double it, or you multiply it by 2, which means you're going to multiply 1 times 2, which is 2. On this side, what is the square root of 2? That is 3. Hello to you too. You can actually, instead of asking me to derive a composite function, maybe what you can do is you can gift me and kindly be on your way. That would be really appreciated. X squared plus 2 plus 1 over x squared is equal to 3. Then I am going to write x squared plus 1 over x squared as my subject. Remember they said if this is equal to that, determine without solving the equation the value of x squared plus 1 over x squared. Excuse me, I said you can kindly gift me and then you can be on your way. That's what I said, because I'm busy helping learners in my country, and you are coming here and asking me about deriving a composite function, which is basically not within the scope of what the learners are doing. So x squared plus 1 over x squared, okay, is equal to 3. Now you take this 2 over. minus 2. Are we together? You take this 2 over, then you are left with x squared plus 1 over x squared. So what is the value then of 1x plus 1 over x squared? There it is. It is actually equal to 1. Determine, without solving the equation, the value of this. So you want to know what this expression is actually equal to. What is the value of this expression? Okay, so by actually doing this, squaring both sides for this equation, you were able to get an expression on the left that has x squared plus 2 plus 1 over x squared. You then isolated x squared and you isolated 1 over x squared. Then you transposed the 2 to get 3 minus 2, which is 1. So that means the value of x squared plus 1 over x squared is actually 1. We are done. Finished. That wasn't too shabby, was it? Yeah, I hope it wasn't, guys. I hope it wasn't. Okay, now let's enter into the world of simultaneous equation before we get into roots and nature of roots. A bit of exponents, maybe a bit of functions, guys. I think I might just sleep at 1 because of some of you people, eh? All right, sorry, you can't ask a question, especially if it's I'm currently busy with grade 11s right now, so you can't ask a question that is not within the scope of what I'm doing. So sorry. Y minus 2x plus 1 is equal to 0. And okay, this guy is really bothering me. Actually, now you are being a nuisance, whoever you are and wherever you're from. Yeah, some people, I'm telling you, some people I think are like sent by an enemy into the life. You'll be doing something and they'll be adamant on something. Okay, y minus 2x plus 1 is equal to 0 and xy is equal to x squared plus 3x plus 2y minus 10. I think one other thing we need to be very much aware of, guys, is that nowadays, I saw, for instance, I don't know if you guys saw the national paper that was written by the grade 12s. So I think a lot of grade 12s were waiting to get a question of simultaneous equation so that they can get the 7 marks that is usually due to them in that section. But this year, in the final end of year paper, that was written last week Friday, the grade 12s, they got the surprise of their life. Because in that question, the simultaneous equation was a word problem. And it was one of those that required you to interpret algebraic language, where they're like saying the sum of 2 numbers is this, and the product and 5 times the product of x and y is equal to x 5 more than x squared. You see, so it was like that type of thing, and people were required to set up an equation, 2 equations based on what they read, and then they were able to then from after setting up the equation, then they would solve those 2 equations simultaneous. Okay, so if we look at this, we get a linear equation, we get one that is quadratic in nature. We take the simple one, we make either x or y the subject. It's very preferable to make the subject of the formula be the variable that has the coefficient that is most favorable. So if you look at y here, it has a coefficient of 1, whereas 2 has a coefficient of -2. So it would be better to make y the subject. You transpose -2, it becomes 2x. You transpose +1, it becomes -1. That is your equation 3. Remember, this was equation 1, this was equation 2. So you make equation 1 equation 3. Then what do you do after that? You substitute equation 3 into which equation? Equation 2. So that means where 2x minus 1 is, what are you substituting in the place of y? 2x minus 1. 2x minus 1. So we write x, this x, followed by y, followed by 2x minus 1, where y is 2x minus 1, equal x squared plus 3x plus 2 into y, we substitute 2x minus 1 minus 10 minus 10. Then from there, after making x or y the subject, we know x or y the subject is 1 mark. 2, substitution, that's the second mark. Then we distribute x times x squared, x times negative 1. Don't forget to distribute the terms to both terms inside the bracket if they are 2 or 3. 2x squared minus x is equal to what? Thank you, Megan, for the donut. Oh my goodness, thank you so much, Megan. Here, I really appreciate that. 4x minus 2 minus 10. I really appreciate when I get gifts. It's a rare occasion. So thank you so much. 2x squared is this term. We transpose the x squared term minus x squared. Minus x remains. We transpose the 3x term. Thank you. Minus 3x. Mr. K. Showman. Minus 4x plus 2 plus 10, because all of these are coming over, so the signs are changing. So the 2x squared was fine. You take the x squared, it becomes negative x squared. The minus x is still in the right place. You transpose the 3x, which was positive, it's negative 3x. 4x, which was positive, becomes negative 4x. Minus 2, which was positive, negative, becomes positive 2. Minus 10, which was negative, becomes positive 10. Okay, now where is my beloved equal sign? Equal to 0 at the end. 2x squared minus x squared, x squared, minus x minus 3x minus 4x, that is minus 8x. And then 2 plus 10 is 12. Then you can either factorize or use quadratic formula depending on what, basically is the feeling at the moment. Factors of 12 plus means same signs. Same signs according to who? The sign of the middle term. Minus minus, we have x and x. Factors of 6 are 6 and 2. Factors of 12 are 6 and 2. 0 factor law, x is equal to 6. X is equal to 2 for the roots. Then we sub the x values where? Into the equation 3 that was waiting. So we sub the x values into equation 3. So that means y is equal to 2 into, in the place of x, what are we substituting? 6 minus 1. And then the other one is y is equal to 2 into 2 minus 1. What's 2 times 6? 12. What's 12 minus 1? 11. Then what's 2 times 2? 4. 4 minus 1. Y is equal to 3. So this is the same thing as actually writing x is 6 and y is 11. As points of intersection, you can write those where x is 2, y is 3. Okay? Okay? Yeah. Right. Let's check just a few, something about real, non-real, and undefined. Look here, guys, we are given an expression. This is something else that you guys need to know. For which values of something is something real, when is something non-real, when is something undefined. So for instance, if you look at this is a, and it's equal to this expression. We have 3x minus 1, the whole thing squared. It's all over 8 plus x into x squared plus 2. Right? So this is an entire fraction, and it's regarded as being a numerical expression, denominator expression. Monomial, because we have a binomial squared in brackets, so it's a monomial. And obviously you have 2 brackets, that is a monomial in and of itself. They're asking for which value of x is a equal to 0. For which values of what? Of x is a equal to 0. So remember, a is 3x minus 1, the whole thing squared, over 8 plus x into x squared plus 2. So we are saying all of that is equal to 0. And the question is, for which value of a is a equal to 0? So remember what I said, guys. When you have a fraction equation, this is the denominator. What we know for a fact is that our x value here cannot be -8, because if x is -8, this whole entire thing will be undefined, right? Yeah, now that's just something to note. So I'm not saying that is the answer, but just something to note. We would write down the LCD, write down the restriction, then after that multiply both sides by the LCD. When that happens, that would be multiplied, this first fraction would be multiplied by that would cancel. So in essence, what we'd be left with would be 3x minus 1, the whole thing squared is equal to 0. This is 3x minus 1 into 3x minus 1. So that means the answer for x is actually equal to 1/3. Now you can't say is equal, well, it's x is equal to 1/3 or 1/3. There's only 1/3. Only one. So this is the value of x for which a will be equal to 0. When x is equal to half. If x is equal to half, then a will be 0. Make sense? So in my head, when I look at this equated to 0, I'm first thinking, in the denominator, can I factorize? No, I can't for both fractions. 2. Is there an LCD? Yes, there is. It is a plus x into x squared plus 2. The restriction, x cannot be -8. Okay? X cannot be -8. No. If you not half, 1/3. It's 1/3. Did I say half? Okay, I am sorry if I said half. I meant 1/3. Then after that, we take that LCD, we multiply by it, both sides. Okay, that means I'm really losing it. I'm going bonkers. So my mistake, right? Then after that, when I multiply both sides by the LCD, this gets eliminated. I'm left with 3x minus 1, the whole thing squared. I solve for x, which means these are two brackets of 3x minus 1. When I write down my roots, x is equal to 1/3, and I hope you understand why I wrote down x is equal to 1/3. I hope so. I really hope so. Then if they ask another question, for which values of x is a undefined? Okay, now remember, what does undefined mean? It means 0 in the denominator. That's what it means. So I just go to the denominator, guys, and I write down what I have in the denominator. 8 plus x into x squared plus 2 is equal to 0. Okay, and all I do there is I use the 0 factor law. 8 plus x is equal to 0, or x squared plus 2 is equal to 0. And I'm sure when you solve this one, you get x is equal to -8. All right, this -8 multiplied by that will give me 0, and 0 times all of that will give me 0. Okay, and then here we just say x has no solution. Okay, x has no solution. We see here, if we take the -2 over, we'll take the square root on both sides, and the square root of a negative number means x has no solution. So I could see that already. The only answer here is x is equal to -8. Those are the values of x for which a is undefined. Okay, yeah, we focus on the denominator. Now let's come down to nature of roots. Solve without solving the equations. Determine the nature of the roots. I'm hoping you understand. What do we do? Can I hear from you in the comment section? If I want to determine the nature of roots without solving the equation, how do I do it, guys? What do I first do? Okay, anyone who wants to really help me out here? Lead us along, Christine. Or like, do we have you can lead us here. I'd love to hear from you guys. And then maybe you can tell me as well, like, yeah. No, if we don't factorize. Remember here they're saying without solving the following equations, determine the nature of their roots. What is the procedure? Thank you, Catherine. We use delta, guys. We use delta. If they say without solving the following equations, determine the nature of roots, then you know that you must use what? Delta. Okay, we must use delta. Okay, I think Christine is going to help me out because I forgot. I think Christine knows what they mean by delta. She can help me out here. And here am I waiting so patiently for Christine to sort of like tell me what do I need to do step by step. So x squared minus 2x plus 1. What do we do? Step number 1. We use delta. But in order to use delta, what has to first happen? So Christine, are you with me? Are you going to help me out?
Delta,
Yeah.
it's b squared minus 4ac.
Sorry?
Delta, it's b squared minus 4ac.
Okay. Yes.
Which is equals to 0.
B
Then you
squared.
substitute.
So you write delta is equal to b squared minus 4ac. Okay, I wrote that down. What do I... Did you say
Then
equal to 0 as well?
no.
Oh, okay. I thought you said that. So what do I
Then you
substitute?
substitute your b squared. It's going to be 2.
Just the number 2.
No, it's gonna be 2 squared minus.
Okay, so the value of b first and foremost is what, Christine?
It's negative 2.
Okay, so I'm going to substitute negative 2. Okay, minus. Then?
Minus 4 bracket 1.
Bracket 1, yes.
And then c is gonna be 1.
Okay, awesome. Then, what's the value?
It's 4. Is it 4?
Yes, 4.
Minus 4,
Mm-hmm.
which is going to be 0.
Okay, then tell me about the roots, because I need the roots to determine the nature of roots. So what's the nature of the roots? Roots are?
That's the part I struggle with. I'm not sure.
The roots are real. That's the first thing. Do you agree? If delta is equal to 0 or greater than 0, two things. If ever you get your answer that delta is greater than 0 or delta is equal to 0, it means that the roots are real. In other words, your roots will be real numbers. There'll be numbers that exist on the number line. That's what it means. Real numbers are numbers that exist on the number line. Okay? Secondly, the roots are rational. Okay? Because 0, okay, we say that 0 is a perfect square. Why is it a perfect square? Because 0 times 0, what does it give you? 0. Right? So we say 0 is a perfect square number. So since it's a perfect square, we say that the roots are rational. The minute this number is a perfect square, we can say that the roots are rational on that basis. Okay, so we should have said delta is equal to 0 and delta is a perfect square. Two things that we can conclude. After delta is equal to 0, we can also say that delta is a what? Is a perfect square. Then we can comment on the roots. So since delta is 0, means the roots are real. Since delta is a perfect square, it means the roots are rational. And then since delta is equal to 0, we say that the roots are also equal. So we comment under three things: real, rational or irrational, equal or unequal. So we conclude and we say these three things on the basis of our value of delta. Are you with me?
Yes.
Okay. Let's look at the second one. Guess we would do the same thing, right?
Yes, you do the same thing.
Yeah, so here, maybe you can help me again. What is my p-value?
The b value is -4.
Thank you. So p squared minus 4ac, that means my p-value is -4. So I put it in brackets squared minus 4ac.
-4 bracket 1
Thank you. C.
-8.
Amen. -8. Okay, then. Yeah, then we do the maths gymnastics then.
16
16.
and 32 -32. No, +32.
Yeah, thank you very much for correcting that. Plus 32. That gives us okay, 48. So two things here about delta. Delta is greater than 0. Delta is not a perfect square. So then what can we conclude about the roots? If delta is greater than 0, does that mean real or non-real? Does that mean that the roots are real or non-real?
They're real.
They are real. 2. If delta is not a perfect square, are the roots rational or irrational? Remember, when it was a perfect square, the roots are rational. But now this number 48 is not a perfect square. So that means the roots are
Irrational.
irrational. And then lastly, since the delta is greater than 0, can the roots be equal or are they unequal?
Unequal.
Exactly, there we go. That wasn't so difficult, was it?
Yeah.
Okay. Are we good? I hope it makes sense. All right. Something that we have not touched on. Let's say delta was a negative number. Let's say you got delta as a negative number. Okay. Because here in the situation, we saw that delta is equal to 0, right?
Yes.
And then we were able to conclude that delta is a perfect square. And from that, we said the roots, because we always comment on the roots. Because delta is 0, we say the roots are real. Furthermore, because delta is a perfect square, we say the roots are rational. So if they are perfect square, we say the roots are rational. If they are not a perfect square, we say the roots are irrational. And then if delta is equal to 0 still, we say the roots are equal. Okay? Yeah. This one, 48. This number is greater than 0. So when delta is greater than 0. But 48 is not a perfect square. Never. So because delta is greater than 0, we say the roots are real. Because delta is not a perfect square, we don't say rational this time. We say irrational.
Irrational.
And then because delta is not 0, it's not equal to 0, it's greater than 0, we say the roots are unequal. But here's the thing, what if we got an answer and we found that delta is -5? What would we say about the roots?
Non-real.
Thank you. Is there more that we can say about the roots? when we say the roots are non-real? Is there more that we can say?
There's nothing else you can say.
Thank you very much. Why? Why is that, Christine?
Because they're not real.
What does not real mean?
That's the only reason I have.
Okay. So, Christine, here's another thing. Just take note of something here. If I was to draw a graph, a parabola that shows non-real is a parabola that does not touch the what? The x-intercept. Because there are no real solutions. In other words, there are no x-intercepts. That's what this means. No critical values, no real roots. Okay? No real roots, no x-intercepts. I mean, this means one and the same thing. Okay? So we can't say anything more about something that does not exist. In other words, we are saying these are imaginary roots. You see? For delta is equal to 48, where you are saying the roots are irrational, this would be a typical example of maybe a graph that shows non-real. That shows irrational and unequal. Those roots would be irrational, literal. Okay, in that it would be x-intercepts that are irrational numbers. And then lastly, for equal roots, if we say delta is equal to 0, a typical example of equal roots would be a parabola that basically has a turning point on the x-axis. There's one real root, one. Okay, and they are equal.
Yes.
So that's how you relate this back to graphs or functions, because it's important to relate it back to graphs and functions. Okay, I don't know if it makes a bit more sense, but yeah, that's how you tie that back to function. If they had said delta is equal to 25, for instance, 25, is it a perfect square number, or is it not a perfect square number?
It's a perfect.
Yeah, it's perfect. So basically, you can take the square root quickly and check, do you get a natural number? If you take the square root and you get a natural number, then you know it's a perfect square number. So delta here is greater than 0, and delta is a perfect square. So when you comment about the roots, what are you going to say? The roots are they real or non-real?
They're real.
Okay. Are they rational or irrational? Since it's a perfect square, does that mean rational or irrational?
Rational.
Good. And then lastly, are the roots equal or unequal?
The roots are equal.
No. They are unequal. Remember, as long as delta is not 0, guys, if delta is not 0, that always implies roots are unequal. The only time the roots are equal is when delta is equal to 0. Delta is 48. Roots are unequal. Delta is not 0. Delta is 25. Roots are unequal. Okay? But if it's a perfect square, roots are rational. If it's not a perfect square, roots are irrational. Obviously, when it's a negative number, only one thing, non-real. If delta is equal to 0, then of course, the roots are equal. Okay? Hey, I hope this makes sense. I hope this is clear for you. These are the conditions that we find our roots being under. Okay, guys, I hope that's clear for all of you. It's very important for you guys to understand this. When you do, then we are good. But when you don't, then it's a problem. Okay. Yeah, I hope it's good. Okay, I think still under nature of roots. Okay. Still under nature of roots, let's look at this question. Yeah, but the thing is, not today. You can't do measurements today. Yeah, but I hear what you're saying. If we come here, we also have to determine the nature of roots. Okay, and they are saying where n cannot be 0. So let's write down here we've got delta is equal to, firstly we need to make sure our equation is standard form. That's what we do when we are determining the nature of roots. Make sure the equation is in standard form. Then after that we identify a, it's 1, b is negative m in the situation, and then c is 2m squared. So we write equation in standard form 2, we identify a, b, and c. 3, we substitute into delta. 4, we get the value of delta, right? When it is a number, we can comment based on that number. Sometimes delta will be in terms of another letter. When it is, then it means we need to interpret that particular expression that we get. In terms of another letter means we are going to get delta as an expression, an algebraic expression. Then we can comment on the roots based on that. B is negative m minus 4a is 1. C is 2m squared. Then negative m, the whole thing squared, gives us positive m squared. Negative 4 times 1 times 2 is negative 8m squared. Then you can see, guys, that m squared minus 8m squared, these are like terms. The variables have the same exponent, so these are like terms. So what we do is we keep the variable with the same exponent, and then we add the like terms. What's 1 minus 8? That's negative 7m squared. But then they had a condition there. It says where m cannot be 0. So there's a stipulated condition that m cannot be 0. Guys, negative 7m squared, what will be the nature of roots here? As long as m is not 0, it means whatever number I substitute here, think about it. If you have negative 7 and you substitute any number, whether it be negative or that number be positive, what happens when you square that negative number? It becomes positive, and then when you take a positive and you multiply it by a negative number, what does it become? A negative number. As long as m is not 0, it means that the roots will never be equal. Never. But all the time, you put any number here, it will come out positive. You put positive number there, it will come out positive. What's a positive times another negative number? You will always be getting a negative number. So since delta is negative 7m squared, I can clearly say that delta is less than 0 if m cannot be 0. Therefore, the roots based on this expression I have here are non-real. Full stop. And maybe my explanation, as you can see, any number I will ever put here in this m, okay, will always be a positive number. But the minute I take that positive number that comes out and multiply it with a negative, it it will always be giving me a negative. You see? So that means any root I will ever get, any delta value will become negative, which means delta is less than 0. What does that mean about the roots? The roots are non-real. Okay. I hope that makes sense. Okay. I see what you are saying there. I see what you're saying there. Just okay. Let me look at some bit of exponents, and then I'll do a bit of financial maths and probability as you've asked, Christine, seeing as though you're writing tomorrow. Okay. Exponents. 3 times 9 to the power x times 5 to the power 2x over 2 to the power 2x plus 3 times 25 to the power x. Hopefully you are good with these and there's no problem, compared to 2 to the power n plus 4 minus 6 times 2 to the power n plus 1 over 5 times 2 to the power n plus 1, compared to 4 to the power x minus 1 over 2 to the power x minus 1. I'm going to look at these questions respectively. So let's look here. What you can see here is only multiply and divide. There's no addition or subtraction of bases here. There's only multiplication and division of bases. When that is the case, we need to change all bases to prime bases. Our calculator is there to help us. So 3 is already prime. It's 3 times 9. Change it to a prime base. It's 3 to the power 2. You put it in brackets, the x on the outside. Times 5 is already prime, and it's 5 to the power 2x. 2 is already prime. It has 2 to the power x plus 3. And then 25. We use our calculator. You just press 25 is equal to shift fact. What happens when you take 25? You press equal, shift, then fact. It will be 5 to the power 2 in brackets to the power x. Okay, what have we just done? We've changed composite bases, bases that are composite number, to prime bases. Okay, we've just taken composite bases and we've changed them to prime bases. And all we do, guys, if 3 is already a base, if there's multiplication and divide, that's what we do. If there's multiplication and division and we can see there are numerical bases multiplied and divided with each other. 3 is 3, dot means multiply. 9 becomes 3 to the power 2. You say 9 is equal to shift fact, you get 3 to the power 2. You keep that in brackets, you raise it to the power x, times 5 to the power 2x. That's prime, that's a prime base, because it's a prime number. 2 is a prime base, 2 to the power 2x plus 3 times 25. 25 can be changed to 5 to the power 2, prime base, raised to the power x. Now you are going to multiply those exponents that need multiplication. And then after that, you are going to collect same bases and apply the division of same base exponents and the subtract and the multiplication of same base exponents so that you can get an answer. Okay, so 3. So I'm going to take 3 times 3 to the power 2x. 2 times x is 2x, times 5 to the power 2x over 2 to the power 2x plus 3 times 5 to the power, what's 2 times x? That's 2x. Then from here, 3 base is the same, 5 base is the same, 2 base goes alone. So I'm going to collect all the bases 3 and take their exponents and apply the law. Those that are in the same position in the numerator, it means I add the exponents. If the base 3 is the same in the denominator, I would subtract. But obviously and evidently from this situation, it's evident that 3 is going to be 1 plus 2x alone there in the numerator. Then the 5 is going to be 5 to the power 2x going down to the denominator minus 2x. Then this base 2, I'm going to say times 2 to the power. Now this is 2x plus 3. Oh, sorry guys, this was not 2, this was 3. I changed it myself. You see, look at how dangerous I can be. I said I wouldn't do this again, but I'm doing it again. I am doing it again. I'm sorry guys. This was supposed to be 3. This was supposed to be 3. See, that changes everything now. Okay, so I'm going to say 1 plus 2x minus, in the denominator I change the sign, minus 2x minus 3. Okay, so for the base 3 I say 1 plus 2x. I go down, then basically it is like 1 plus 2x. It's all in the numerator what I'm doing. But then if I take this up, I subtract 2x, I subtract 3. This sign changes, it becomes negative 2x. This sign changes, this becomes negative 3. So that means 3, what's 1? What's 2x minus 2x? That's 0. That's 1 minus 3, that is negative 2, times 5 to the power 2x minus 2x, that's 5 to the power 0. And that's it. So we have an answer of 3 to the power negative 2 times 5 to the power 0. Okay, and then finally our answer is 1 over 3 to the power 2, because 3 to the power negative 2 can be written as a fraction. 3 goes down to the denominator, the exponent changes from negative to positive, then 1 gets left behind in the numerator. We get an answer of 1 over 9. Remember, 5 to the power 0 is 1. 1 over 9 times 1 is actually 1 over 9. Okay. So initially, that question may have looked the way it did, but it is not difficult. It's a matter of changing all bases that are composite numbers to prime bases and writing them in exponent form. If you don't know what the number is, you take the number, you press equal, you press shift, you press fact. 25 will be written as 5 to the power 2, and you write it in brackets, you put the exponent on the outside, then you multiply the two exponents so that you get the exponent that is supposed to be there. Okay, so you do that with all the bases that are prime, that are composite. 9, 3 to the power 2, you multiply, and so it goes. Let's look at this one. Slightly different from this one, because this one had multiply and divide. This one has subtraction in it, and it also has division. So how do we proceed with this question? Especially in the numerator, you can see 2 to the power n plus 4 minus 6 times 2 to the power n plus 1. Yes, Sbonga, we split. This is where we do the split method. So where the subtraction, addition, and division. Subtraction, division, subtraction, addition, and division. We split, okay, the exponent. I love it, okay, especially because we see that 2 as a base is raised to the power n, so it's the same coefficient of n is 1, and here 2 is also raised to the power n, so the splitting and dividing method will help. We say 2 to the power n times 2 to the power 4. That's how we get 2 to the power n plus 4 in its original state, minus 6 times 2 to the power n times 2 to the power 1. We are splitting the bases, guys, over 5 times 2 to the power n times 2 to the power 1. Then in the numerator, we can see there's a common factor of 2 to the power n. We take out that base, minus 6 times 2 over what? Over 5 times 2 to the power n times 2. Now, cancelling is possible. Why is it possible? because it's not across an addition and subtraction sign. The 2 to the power n has a relationship of multiply. In the numerator, the 2 to the power n has a relationship of multiply with 5 and 2 in the denominator, so cancellation can happen because it's not across an addition or subtraction sign. What do we get left with at the top? 2 to the power 14 is 16. 6 times 2 is 12, so we have 16 minus 12. In the denominator, we have 5 times 2, which is 10. So what's 16 minus 12? It's 4 over what? Over 10. When we simplify, that is 2 over 5. So yes, guys, let's be familiar with the split. Take out the highest common factor with the exponent base, with the exponent variable, sorry. Okay, but remember, guys, when the coefficients of the variables are the same, common factor can be taken out. When the coefficient of the exponent, one is 2 times the other, we can use K method. So it's very important we understand which one it is. Then we simplify. Okay, we simplify, cancel. If there is common numerator and denominator, we cancel. We don't cancel across an addition, but we can cancel because we are multiplying. There's a relationship of multiply with this 2 to the power n and this 2 to the power n with everything else, either in the numerator or the denominator. Then we simplify. 2 to the power 4 is 16, 6 times 2 is 12, over 5 times 2, which is 10. We simplify, we get the answer. Okay, let's look at this question. It's also a simplifying question, right? This one, if you look at it closely, 4 to the power x is actually 2 to the power 2x. This is us using our prime base, changing 4 to 2 to the power 2 raised to the power x minus 1 over 2 to the power x minus 1. Then you can see that 2 to the power x, you can swap around this x and this 2. 2 to the power x or raised to the power 2 minus 1 over 2 to the power x minus 1. At this stage, guys, what can we do? This is a difference of 2 perfect squares. 2 to the power x all squared is a perfect square. 1 is a perfect square. So what I can do is I can open 2 brackets there at the top. 2 to the power x, 2 of them. That is the square root of 2 to the power x squared. It's 2 to the power x times 2 to the power x. And it works out because if the bases are the same, we multiply the bases. Then what happens to the exponents? We add them. So that 2 to the power